Hello, folks. We are back again with another interview question. And this time, our interviewee is going to be Dev, and I will get to have perks of interviewing him. And yeah, maybe trouble him as much as he did me last time around. So, yeah, this time I
Man,
think we have a.
I'm feeling really nervous now.
Yeah. See,
अब
now
I know that
how tables have turned, man. Yeah.
Okay.
So
okay.
this time we have a very fun problem. So what we now are going to do is, maybe look at a linked list problem here. And the question we have for Dev is this. So let's assume that, we have a linked list which stores, each digit of a number. And the goal is to add two such lists, which would have which would give you another list which would be the correct numerical representation of their added values. So Dave, one example for you here is, let's say the number is 123. So we would list them in the list representation as, the lowest or the lowest most digit first,
Hmm.
and then we'll proceed to the higher uh, 10th place, 100th place, and so on, right? And
Okay.
similarly,
So the last node is actually the most significant digit.
last node of the list.
Uh,
Yes,
hmm.
correct.
Okay.
And similarly here, the second number will also be like, in the
Hmm.
reverse order, and
Hmm.
we expect the answer to be in reverse order as well.
Okay. And can the number be negative as well? Right.
That's a good question. For now, let's assume it's not negative, so
Okay.
all are like unsigned integers,
Hmm.
only positive
Okay.
integers.
Oh, so okay, no negative, only positive. Okay.
Hmm.
And then what would be the range of these digits, right? Like how big this number can be, or the list can be.
List can be whatever size it can. Like there is
Okay.
no limit as such, whatever the memory
Okay.
allows.
Okay. And I will be given the pointer, the head pointer, or the pointer to this node, right? 3 and
Correct,
9.
correct, correct.
Right.
And you are
So
expected to
Like
return,
two pointers, two node
right?
point, two node
Yeah,
head pointers.
okay, and I'm
Like it
expected to
gives the
return.
node pointer in return.
yeah, exactly.
Yes.
And you are free to choose the definition of the list, whatever you want to add there.
Okay. Okay. Okay.
And for now, let's assume it's a singly linked list.
Single link list.
Yeah.
Okay. 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 Let me. So the first approach that I can think of is that I will keep adding the corresponding digits, like just how we
Mm-hmm.
add, two
Mm-hmm.
numbers, and then if like their addition goes beyond like 9, then I will use one carry forward, right, to the
Mm-hmm.
next node.
Okay.
And if there is no carry forward, then I'll just add them and then create a new node, and then the value of that new node would be the addition of these two digits, and then depending on the carry, I can add into the next node or not, right? That could
Okay.
be a way forward.
Hmm.
So do you want me to write down this code first, or do you want me to think of any other approach?
I think let's start with the code.
Okay, okay. So then, what I would be thinking is that I will be given like, I don't have to write the main function and all those things,
No, no.
right? I'll just have to write the exact function that takes to the pointer to this to linked list, and then return a pointer to the
Hmm.
final linked list. Okay. Okay. So let me create one struct first. Struct. So I'll call it as node, and then I think there is just one digit, so I'll have one digit which is okay, digit. I will use it as a digit, and then have the next pointer as well. So struct node pointer, and this would be next. Okay, and then I will be given okay, I will respond with the actual node pointer of the final linked list, and then I can say okay, add. Okay, I'm using C, so I'll add two numbers. Okay, and then struct, I will be given two pointers, so struct node list one or the number one. I would say list one, it's a better choice. And then list two. Okay, and okay, and what I can do is I can traverse both of the linked list, and then add the digits correspondingly. So what I can do is, so there would be cases where, like, even in this given case, right, like the second list is bigger than the first list, right? So I can
Right.
add 9 plus 3, which is 12, and then have 2 as the digit of that node, and then the carry forward would be 1. And similarly, like, I will reach to this 1 and 8, right? So that would be added to that node, and then if there is something pending in one of the linked list, I would iterate through that, going forward, and then add to the final linked list.
Correct.
Right, so that's the case. Now, until the linked list is not null, I will, until both of them are not null. So list 1 is not null, and list 2 is not null. Okay, so while both of not null, and then I will use a counter or a carry value. So let me use this as a int carry. Initially it is value 0, so I will add these two digits. List 1 and 2 both are not null, so I can access those two digits. List 1 digit plus list 2 digit, which is, let's say, my int. I'll have another variable which is initially 0, let's say, then have sum of these two digits as sum. And then what next I can do is, if I add these two digits, can I ever go beyond 19? So I'm trying to figure out if the carry can be more than 1 or not. So if both the digits are 9 and 9, so that's 18, and then from previous 9 and 9, that's 13. So I can only have maximum 1 carry forward, right? So what I'm thinking is, let's say I have 9 these numbers, right? So I'm trying to figure out if only the like only this condition would be sufficient to check the carry or not, right? Like this, if the sum is greater than equal to 10, then I can say, okay, the sum would be sum minus, I think I can just subtract the 10 value, right? Let's say it's 11, then 1 is the, okay, I need to, okay, I am trying, okay, and then carry would be 1. So I'm trying to figure out if the carry can be more than 1 or not, right? So if 9 and 9 is added, then that would be 8, 18. So 8 and 1 is given forward, and so 1, 9, 10 and 9, so that's 9, and then 9 and 9, 18, so that's again 9 and 1, something like that, right? So I'm never going beyond like 19.
Right.
So I can just do this. If let's say 12, then I can just subtract 10, and then that would be sum, and then carry would be 1, right? Okay, I'm constantly going, it's constantly going up for me. I don't know, for
It's
some reason.
scrolling down, is it?
Yeah, it's scrolling up again and again. Yeah. Oh, down. Yes. So maybe because of the trusty engineer, can you point somewhere downwards here. Okay, let me go forward. Yes, okay, now it's fine.
Does it work?
Yeah, this worked, I guess. So now what I can do is I need to create a linked list node.
No, it's not working.
It is working.
I
It
think
is.
whenever you change the cursor, it changes for me as well.
Okay, 1 minute. Now I will not touch it. You can go.
Okay. So struct node pointer. So what I'm trying to do is to have another function. So I wanted to have this function modular, like this code modular. So I'll create another function, and that's create node or something, right? And then I will be passed a value, int value, and that would be the value of that struct node ptr. And then I can say, okay, so this is, I can just do this malloc. Don't have to typecast, I guess. So struct node, and then pointer value would be value. Okay, it's instead of value, it's a digit. And then pointer, and next would be null. And then I return just pointer. Okay, let me have a space here and then here as well. So that is fine, I think. Yeah, assign value to digit and then next null. Okay, then the what I can do here is that just call this function create struct node pointer new node, and then create node, and then what is the value is sum, right? So what I can do here is that one more thing is that I need to do carry sum as well. So carry comes from the previous number. So if the carry is there, then I'll also have to add that. So more than 10 minus, now I can say. So sum is the one, I think. And then I need to maintain a linked list as well. So I'll create a head pointer to the new linked list, struct node, head is equal to null. And then what I can do here is that if it is okay, I need to again keep track of a current pointer as well. Struct node, I'll say current pointer, which is the pointer in the linked list where I'm going to add the next node, right? So what I can do is my head will always be pointing to the first node. So I cannot really move forward. If my new node, if my head is null, then my head would become new node, right? And then my current would also become new node. Right? And then else, in the else case, now I have more than one node already present. So the current next would be new node, right? And then current would become now point to the new node. So what I'm trying to do here is that I'll just explain what I did here. Okay, with this on here only. So let's say I have 5 and then 6 and then 7. So my head is pointing to, okay, I'm going back down. So head is pointing to 5, and then my current is pointing to 7. And this would be next null, right? So what I can do is my head is pointing to 5, current is pointing to 7. Now I'm adding a new node, so I'll just use current next is equal to new node. So that would, now the current would point to the new node, and then my new node will become the current, right? So let's say I'm adding 8 here. So my current would become 8, right? and then I don't have to care about the next because the 8 was already having null in the next node, right? So that is fine, I think. Okay, and then okay, I think this loop should do its job now. I don't have to worry about anything else. I guess this is done. Now I'll have to check for remaining elements in any of the linked list. If let's say list is 1 is not null, then what I have to do is to copy everything, but also I have to take care of all these things. So I'll just copy this here. Okay. So one example I can just simply do is, if my list 1 is null, I'll just return list 2. Okay. If my list 2 is null, I'll just return list 1. Okay. So that means if one of the list is empty already, then I don't have to worry about what the number is. So I'll just return another list, right? And then, okay. Now let's say my list is not empty. List 1 is not empty. So I'll have to still take care of the carry here. Okay. And then else, if there is nothing, I'll have to change the carry with 0. Because sum is less than 9, so I will have to update the carry is equal to 0, because otherwise this carry is always 1 and it will always keep adding to the numbers. Like, and then now list 1 is not equal to null. So what I can do now here is that I already have the carry. So just keep adding to the numbers. Let's say 8 here, 7 is 1, I have a carry, so I'll add. If it is already 9, so it could also create a carry forward, right? So if list 1 is not null, so one thing I can do is, I'm for sure is that I just trying to remove, reduce the code redundancy. So one thing I'm very sure of is that either list 1 is null or list 2 is null at this point. If both of were not null, then it have executed, it wouldn't have reached the line number 64, right?
Okay.
So either one of the list is empty, right? So what I can do is I can just create struct node. Okay, can I use the pointer only here? No, pointer cannot be used. Node star. Then I can use it, let's say tmp. Now that would be, let's say, list 1. Okay, if tmp is null, then my tmp would become list 2. Do you get my point here? That I'm just trying to
get the unempty list.
Yes, yeah, non-empty list. And now I'll do just the same thing here. The sum would become tmp digit plus carry. If sum is greater than equal to 10, so here the sum could only be 10. It cannot be more than 10. It can be. No, it cannot be. Because carry would always be 1 and then digit can be 9. So if the sum is equal to 10, it can never be more than 10. So okay, I can do both. So my carry would be 1, and then sum would be 0. I don't have to do that, but okay, I'll do that. Minus 10. Okay, carry is 1, sum is 10, and then I'll just do the same thing, create a node, just copy paste it here, created a node, and then add it to the the same way, I guess. If one of them is null already, so that would have already returned. So now I can just use this. I don't have to worry about one of the list, because my head is never null if I reach at this point, right? Because if one of the list was empty, I would have already returned. Now none of the list are not like, both lists are non-empty, so it would have initialized head only already, right? So
Okay.
till the time I reach here, the head is already initialized, so I don't have to worry about that. And then I'll have to, so what if, let's say, after even exhausting the last node, if I have a carry, like even the last digit can have a carry, right? So I'll have to forward that as well. Okay, here I'm also missing the one carry is equal to 0. And then if carry is there, still there, that means I'll have to create a new node just like this, and then okay, I can do this, simply copy paste it. Instead of sum, it would be carry. New node, current is, I don't have to do this now because it's end of the list already. So now I can just return return head. Okay, so yeah, do you want me to go through the some examples here, or
maybe
or-
try run.
Just go through your code. Do you see a mistake?
okay?
Maybe I think let him dry run.
Yeah, you can try run. Yeah, maybe
Okay.
maybe you will see a mistake.
Okay, so just let me just briefly go over the code if I'm missing anything, and then I'll dry run, right?
Okay.
So I'm creating a new node, doing the malloc size of struct node, and then pointer digit value, next null, pointer returning the pointer. Okay, add to the numbers, list 1, list 2, carry sum, list 1 is null, then return list 2, list 2 is null, return list 1, add current pointer is null, list 1 is not null, list 2 is not null, so both of them are not null. I'll do list 1 digit, list 2 digit, and then add carry. Carry is already 0 here, I think. Yes, so I don't have to worry about that. Now sum is if greater than 10. Let's say 17 is the sum, so then I will have one carry. So 1 is the carry, then 17 is 7, right? Yes. And then if sum is less than 10, that means the carry is not there. So I'll reset the carry 1, and then add create a new node, add sum there. Then if head is already null, then I'll initialize head with new node and current with new node, and then else current next is new node. Okay, and current is new node actually, and then okay, temporary is list 1. If temporary is already null, then temporary would be list 2. Temporary is not null, so temp digit. The temp is never going ahead. And similarly there as well, I think. Next, temp is temp next. Okay, and then similarly here as well, I need to advance both of the pointers. So list 1 is list 1 next. Okay, I think it's list 2, list 2 next. Okay, and then here I don't have to worry about what is the value. Okay, I think I'm done. Do you see any problem in the code, or I can, if you want me to, I can walk through like dry run over the code.
Because list 2 is shorter than list 1.
Sorry,
What if list 2 is shorter than list 1?
list 2 is shorter than list 1, so I think yes, it would do that. Yes, it would do that. List 2 is shorter, so list 2 will be empty already, so my temp will not be null at this point. So this should be able to handle that case.
So you assign list 1 to temp and you see
Yes.
whether the list 1 has ended. And if
Yes.
list 1 has ended, you assign temp to list 2. Where do you check
Yes.
list 2 is shorter?
No, so if the list 2 is shorter, then I would not reach here. I will like this line number 69 will not be executed. So only 67 is executed. So my temp will be equal to list 1. So I'll go forward with that only, right?
If your temp is equal to list 1 and if it is equal to null, then you assign it to, yeah.
Yes, yeah. So I'm basically trying to figure out which one is shorter here. Like which one is
So he's
not
assuming
ended.
list 1 is shorter, and if it is
Yes.
not, then changing it to list.
Yes,
Yeah.
I would have done that like if else, but I wanted
Fair,
to,
I think this works.
small codes. Yeah.
Okay.
Yeah, so.
Okay.
Yeah.
Right.
Do you see any syntax, any small mistake in your code?
Okay, like I think maybe syntax maybe there.
A syntax is fine. There is a very small mistake.
Okay.
Just check your structure.
I'll check my structure. Digit and next. Digit and next structure node.
So what is the name of your current pointer?
Okay, where? What is the name of my current pointer? 32.
39.
39, okay. Yes. Okay. I am using that current pointer. Maybe yes. I should have used that.
Change the name, man.
Yes. Okay. The which occurrence is lesser, so I could do that. This occurrence is lesser. Oh man, I was trying to be more readable, so I used this as current pointer because current could be anything. So I wanted that, but then like my previous old days where I just used current, so that got me here. Okay. Okay, I hope that I didn't make any another syntax error, I guess. Okay.
So let's say if
Okay. So one more thing is that I am declaring this. Okay. Yeah, that's fine, I guess. Like I'm doing this new node again and again, but since it's part of the block, so it won't be any problem.
Yeah,
right?
it's within the scope. It's a local device.
Yes. I would have just used just a single pointer without creating multiple things, right? Just create a new node here, right? So that wouldn't have created, pointer again and again. That's the, I think it would say of n error, like of n size of memory as well.
Okay.
Yes.
So if you look at your code, so line number 50, there's a good chunk of duplication in it. Can you
Okay.
There's a chunk of duplication of the code.
Okay.
For example, line number 44 to 47, that logic is getting checked again.
Yes.
But if it is more than that, you create a new node that is again a duplicate logic downstairs.
Right. Okay. Here again. Yes. So what you're trying to say is I could use some another function and then just call that function with. Okay. I agree. Yes.
Or maybe can you use another way to do it? Like another
way. Okay. Another way.
Yeah. Is it so that our viewers are also aware of another method?
Like just this logic or this whole?
No, just the if else logic. Yeah.
Okay. Okay, so that I could do. Like I
Maybe-
can just okay, where was I? So here I'm doing the same
I
thing
think
again, I guess.
Rajat, maybe yeah.
Yeah.
So you can. So there's a way to solve. Do you see a pin on the top? Just click that.
Yes. Okay, unpin now.
Now you should not have any problem.
Okay, so what I can do is I'll just use carry as some %10.
Yeah.
So that should
Modulo.
do,
Yeah.
yes, module of
So
10.
you don't have to check again and again whether
Right.
so it would get replaced.
Yes, so if else would not be there, yes.
Is
And
the
some-
modulo operator correct here?
I should divide it by 10, and then some would be some %10. Right, so that should yeah. So I should remove this entirely, I guess. Yes, okay.
Yeah.
Yeah, just 2 lines instead of 4 5 lines. Carry and then sum. Carry should be first calculated and then sum should be calculated. Yeah, because sum is being
Will be
used in
override.
calculating carry. Yes.
Nice.
Okay, that's all. Okay. Yeah.
So I think great job.
Okay.
So, and one thing I liked about this was you were not shy away of creating new functions.
Yeah.
Like create node, right? That solves 2 problems. One is it declutters the code, and secondly, it also solves the allocation. So sometimes mistakenly people might just not think. So in this case anyway, we have to allocate it dynamically. But in some other cases where you allocate some variables on stack, and then by accident return it to the caller function, that would not have any value. So that's why I think you have taken care of everything by just not shying away from creating new subroutines.
Yeah.
So that's good. Rajat, any comments from your side?
Yeah, the code looks okay.
Okay.
Though, as I said, you can make it more modular.
Right. Yeah, I think so.
Still, but I think I mean, given the time constraint and
I think this is a
setup?
perfect solution.
Yeah.
Yeah. I think these 3 lines can be reduced to just 1 line, maybe calling another function or something. Yes.
Okay. Cool. I think we have okay. So before we wind off, what modifications do you think they will have to be made in the code? If let's say, can you scroll up? So here our assumption was that the linked list is already in the reversed order of the digits. So the first node contained the least significant digit, right? Now what if that was not the case? So instead of 3 to 1, it was 1 to 3. So
okay,
what modifications do you think would be needed?
I think then okay, let me just use 1 2 3. Okay, just use 1 2 3. So this would be a linked list of like this 1 and then 2 and then 3, right?
Yeah.
And then similarly, let's say 7 8 9 9 would be of linked list. Okay, what I'm doing wrong. 7 8 9 and 9, right? Okay, this is the case, let's say. Then I cannot really add 7 and 1 here correspondingly. So anyway, like I'll again have to do some sort of reversal here, because I will end up adding 3 with 9.
Okay.
I should only add 3 with 9 instead of adding from the front. So what I can do is, in that case, the one straightforward solution would be that I just reverse both of the linked list, right? So and then do the same function call here, right? Just add 2 numbers. All I have to do is to reverse the linked list first, and then when I get the linked list back, I reverse it again, so that the response would be what you are looking for, right? So that is like it won't impact the time complexity it just takes off n another plus of n plus of n, right? So that's the case. Like what I was trying to say is that of n is for n and m is for reversal, and then again iterating through the linked list would again be of n plus m, right? So that should not change anything.
And what about space complexity?
Okay, the reversal would again I think one important thing to call out here is that I would be changing the inputs here. So whatever linked list that you are given to me,
I think
I will be changing that linked list, right? So
that would be not a good practice, right? You should not
right. Yes. So it would alter the input values, right? Input linked list. Now, second thing I could do is I can just reverse the linked list again before responding back to you, right? So that's again like it would take off n plus m another set of time here. But then the space would be same, I guess, because I'm not really using this another space. I'm not creating another linked list. I'm just changing the pointers from backward direction to forward direction, or forward to backward. Yes.
So essentially, what you are saying is you would first reverse the linked list to process it, and then once you are done with the processing, you would again reverse it so that you don't play around.
Right. Yeah. I think if it is like use once and throw, the inputs are like use once and throw, then I would worry about the inputs being altered. But if let's say it's really being used after this function call, then I should be modifying them back to the same state.
So asking a dumb question. So line number 12, traversing through a linked list, like where we created a new linked list, should not be it max of m and n rather than n plus m.
Sorry, can you repeat the question?
So where we are creating a new linked list means the whole while logic, the time complexity of that, instead of being order of n plus m, it should be order of max of m and n, right?
Yes, but
you're
like
only traversing the biggest list.
Yes. I'm like I will be traversing both of the linked list. So it would be like
time, right? You will be traversing. The time and complexity will only go to the maximum size of the linked list. Which one is the maximum?
Yes, of course. So this would again be like the maximum of like order of maximum of m or n, right? Like if n is way smaller than m, then it would be like O of m, right? Something like O of m. Yes, I think.
Anyway, I think the first one supersedes both of them. So.
Yes, the first one supersedes. So ultimately, it is order of n plus.
Yeah. Okay.
Nice. Okay.
Another approach I could think like instead of reversing anything, so that would even be less optimized solution, but it's another solution as well. So I just trying to point out that what I typically do is that okay, so let me go here somewhere. So what I can do is I can think of solving this through recursion as well. So what I do is like whenever I'm trying to do something from like this is what I'm trying is like so when you call the recursion first, right? Let's say this is a call and then you internally call again, right? Internally call again, right? So initially you were traversing 1 here, then 2 here, right? Then 3 here, right? So what I would have done is in this call I would have added 3 plus 9, right? And then so in that case what I first do is I'll calculate the size of the both linked list, which is, let's say here it's 3, here it's 4, right? And then what I do is in the first recursive call, so I'll call with this function. So my function prototype would be, let's say call and then head 1, then head 2, right? Or the list 1, list 2, right? I should use list 1, list 2. And then what I do is, with that, I'll also use the size 1 and then size 2, right?
Okay.
And then what I do is I'll also use the current position. So which node I am traversing now, right? So if my current node is 0, right? And I know that the other list contains more than this list, right? So while the difference, let's say this is 3, this is 4. So I wouldn't advance the list 1 pointer here, but I will advance the list 2 pointer. Call. So okay, I think this modified something. Okay, and then in the list, the list 1 will be this one only. List 1 will be this one only, and the list 2 would be 1. Okay, now it's 7, and then 8, 9, and then 9. So now I know that, okay, these are perfectly aligned.
So you're
right?
basically aligning.
Yes, yes. So and because of that, I need to take care of the current. So I'll only until the difference, the size 2 minus size 1, I'll know that, okay, the current initially, this current is 0, right? Here current is 0, here current is 1, right? In this call current is 0, in this call current is 1, in this call current is 2, in this call current is 3.
Right.
So until the difference, like the difference of this size and size 2 minus size 1, if it is less than current, then I'll only increase the another linked list which is bigger, right?
So basically, current can only go to max of the size.
Both size, yes. And now what I do is I'll just increment 3 and 9, add 3 and 9, and then return the carry.
Okay.
Yes, right. And then again here I do the same thing, return the carry, do the same thing, return the carry, right?
Yeah.
And this way, and then also here in this call, when I do that, like while returning, I need to return two things. Either because I'll have to return the head of the linked list, right? So here 3 plus 9. Now my head is, the node is 3 plus 9, which is 2, right? So that node has to be returned with second this one, right? So I'll typically have to return two values. And so what I do is I return one value via the return, and then another via as just a function, call by reference, a variable call by variable by reference, right?
Or you could have a static carry.
Yes. Yeah, static carry as well. Yeah. So this way again, like I'm not really improving the time or the space complexity, right? Here I'm again using some stack, so this would be of
Yeah, you are basically using the programming construct. Yeah.
Yes, max of n comma n, right? Because
Right.
that
But
would be
it's
the depth.
but I would still say it's a novel solution. I think if people want to try it out, implementing like what you said, go ahead, feel free.
But looks very error prone if not coded.
Yes,
And plus, the assumption, the initial
And
assumption we made, right?
definitely a pain to debug.
Yeah.
And
I think there are some solutions that can only be solved via this way, but yeah, this is not the proper solution for this question.
Yeah.
It's just another solution, so just for thinking.
Yeah.
Nice. Yeah. Awesome. I think we are almost at time.
Okay. Before we wrap up, I would like to summarize. What was good about today's and what we should learn about it.
Okay.
So one of the things is that you should not derail yourself. Sometimes interviewers can split up, can put things into mind, can point out something that can derail you from your solution. You have to be confident that and come back to your solution and defend your solution. Sometimes interviewers just want to derail you, just want to see how much confidence you have on your solution. The second thing that was good about was that once you have coded your solution, always first do a dry run. Or in your mind, it's fine. You can take a comment and say, okay, now it is the final solution that I have.
Right.
and obviously, and I think this was a good interview and everything went fine.
One more point to add was they were speaking his thoughts out loud. So that's
Yes.
very important, because when you're not taking interview face to face, right? It's quite challenging for both the parties to know what is going on
Right.
the other person's mind, right? So
Yeah.
speaking out loud every statement really helps.
Mm.
That was a good point.
Okay.
Okay.
All right, with that I think we can conclude for today. We'll be back hopefully with the next round, and this time Rajat would be on the hot seat.
Yeah.
Okay, nice.
Okay.
Okay.
Awesome. Chalo, bye bye, take care.
Bye bye. Take care.